Hello everyone. We will discuss further questions of assignment of data science. Question number 5. Discuss the importance of dimensionality reduction in machine learning. Compare and contrast feature extraction and feature selection as two approaches to dimensionality reduction and provide examples of techniques used for each approach. So importance of dimensionality reduction. Dimensionality reduction is the process of reducing the number of input features in a data set while preserving as much relevant information as possible. Why it's important reduces computational cost, fewer features, faster model training and prediction. Avoid the curse of dimensionality. High dimensional data can make models complex and less generalizable, removes noise and redundancy, eliminates irrelevant or highly correlated features, improve model performance, leads to better accuracy and generalization on unseen data, enhances visualization, enables plotting of high dimensional data in 2D or 3D for understanding patterns. Two main approaches of dimensional reduction is feature selection and feature extraction. What is feature selection? Selecting a subset of existing features that are most relevant to the output variable. Goal is to keep the original features that contribute most to prediction. Examples of techniques are filter methods, then we have wrapper methods, then we have embedded methods, then feature extraction, transforming the original features into a new set of features that capture essential information. So our goal is to create new features by combining or projecting existing ones. So example of techniques are principal component analysis, then we have linear discriminant analysis, then we have T-distributed stochastic neighbor embedding, and then autoencoders in deep learning. Common comparison, so data transformation keeps original features, creates new transferred features. Interpretability, easy to interpret, harder to interpret. Information loss, may retain redundant info, may lose some interpretability but captures more structure. Computation, simpler, can be computationally heavy. For example, selecting top 10 most correlated features using PCA to project data into top 2 principal components. For example, suppose we have a data set with 100 features for predicting customer churn. Feature selection, pick only the top 20 features that most influence churn using chi-square or lasso. Feature extraction uses PCA to transform the 100 features into 10 new principal components that captures 95% of the variance. Now we have question number 6. Overfitting and underfitting in the context of machine learning model. Describe how these issues can be identified and list strategies to prevent or mitigate them. So overfitting occurs when a machine learning model learns too well from the training data, including its noise and random fluctuations, instead of just the underlying pattern. As a result, it performs very well on training data but poorly on unseen data. For example, a decision tree that grows too deep and memorizes every training instance will overfit. Identification are training accuracy very high, testing accuracy very low, learning curve, large gap between training and validation errors, prevention and mitigation. Use cross-validation to tune model complexity, apply regularization, use pruning in decision trees, collect more data or add noise to training, use dropout for neural networks and simplify the model, reduce parameters or features. What is underfitting? Underfitting happens when the model is too simple to capture the underlying data patterns. It performs poorly on both training and test data. For example, using a linear model for a dataset that clearly follows a non-linear pattern. Identification is training accuracy low, testing accuracy also low, and learning curve, both training and validation errors are high. Prevention or mitigation, increase model complexity, reduce regularization strength, ensure features are informative and sufficient, train longer or tune hyperparameters properly. So for this video, we have seen question number 5 and 6. In further videos, we will discuss more questions. Thank you.